In this video, we'll talk about how you can generalize the confidence interval of any value, but let's go back first to the packet and look at the example there, which is number 6 on the packet on confidence intervals. And just to sort of recap, there's two common types of statistical inference, one of which is confidence intervals, and one of which we'll talk about later is called significance tests. And like kind of the main idea of the second half of this course is understanding different types of tests and confidence intervals and so forth. And you know, those are important to the subject as being ways of determining the validity of our data. Sorry, I'm a little tired. But let's look at question number 6. This is a sample of 4,000 students in Ohio were found to have a mean SAT score of X bar equal to 1076. Similar to our test question on SAT scores with standard deviation, it says we'd like to estimate the SAT score mu for the students in Ohio. And we want to know essentially how close is this value to being correct. Consider this sample as an SRS from a normal population with sigma equal to 200. So we're just kind of assuming, okay, this is a simple random sample, these 4,000 students, from a normal population, which has a standard deviation of 200. And, you know, just like we said, we have to have these assumptions in order to be able to take this into account. So the first question, it says, what is the standard deviation of the sampling distribution? And again, that is always sigma divided by the square root of n. So here we're told that the standard deviation of our population is 200, something which we could make an assumption about from the sample, which is not always wise, but you know, is often how it's done. And then the square root of n would be the sample size, which in this case we have 4,000 students in our sample. So standard deviation should be a lot more compact than a random student because there's so many of them. And we'd expect our mean to be closer just given that our sample is larger. So if we take 200 divided by the square root of 40, just 4,000, that would give us approximately 3.162 for the standard deviation of our sampling distribution. And then if we want to calculate, say for example, a 95% confidence interval, we know that we want to do twice the standard deviation above and below the mean, because it's like, again, X bar is like the central. We're assuming this is the mean of the sampling distribution, and then we, you know, our confidence interval would take on twice the standard deviation for 95% of the data based on the 68, 95, 99.7 rule. So if we just did twice that, so times 2, that would give us 6.32-ish for our twice the standard deviation, and that's going to be our margin of error, 6.32. This is one way that we could write that as a confidence interval. And we could also write it, the confidence interval, as like using interval notation as we have in the past. So that would just be taking my calculated mean from my sample and adding twice the standard deviation of the sample distribution. So the top end would be 1082, and we'll just go ahead and round that to the nearest whole number. And that'd be the top end, and then the bottom end would be the mean minus 6.32, which would come out to be about 1070. And you might want to round them both up to actually include 95% of the data, because notice if I'm rounding this to 1070, I'm actually cutting off a little bit by rounding it up. But, you know, at the end of the day, I wouldn't really sweat it. You could write it with more decimal accuracy if you want. And I know I miswrote this. This would be 1082. I should not record these videos when I'm so tired, but that's okay. And again, at the end of the day, we get an interval of confidence for the actual mean. And kind of just to recap, the mu represents the mean of the actual population of all SAT students in Ohio. And so we know the mean should be like, we're 95% sure the mean should be in this interval based on our calculated value. Again, we're not sure, but it gives us this level of confidence. Now, if we want to say figure out what's an 80% confidence level or something else, I'll go ahead and put that in the next video to talk about a little bit more about how to change the confidence interval value to something else. Because again, here we're using the 95% rule, which we know is 2 standard deviations. 95% of data falls within 2 standard deviations of the mean. That's kind of how we're determining all this. But let's say we wanted to know what's a 92% confidence interval or 90%. Basically, we can use z-scores to do that. And we'll get that in the video right below.